All right, we've sort of compiled all the information that we gained by spending a few hours measuring and checking over this barn structure. If you're not accustomed to looking at working drawings, there's like a view here and a plan view here, and then this is a detail here. So there's three major items here that we're going to discuss. I began by laying out the footprint of the building, making measurements just as far as length of sides and as well as the neighbor building, and I got distances between the two of them, and it established for me that the true width of the building as designed and built was at the back, and the length was the same overall, but at the front it has grown wider, and the distance between it and the neighbor building has grown smaller up here. So it seems to me that this wall has at the front it's migrated out, and we established that by measuring around. We also went down to the tree and over and laid over the position of the tree, and I show 16 feet of the building here as the potential pole angle that we could get from the tree. And you can also come over with a pillow block, would just run over to a neighboring tree or structure with a pulley, and then you can go around that pulley and pull against that around the corner and pull right out to the front and even over in this direction. So we have those options available to us. However, I don't know that pulling is going to be the key. Originally, I thought that opening up a garage door and having matched lumber sheathing only on one face of the barn to boot had created a weakness that had over time allowed the front to shift. It certainly hasn't helped whatsoever. However, I did set up a laser transit inside the building here, so I had a laser line going all the way around, and I went to these four green X locations, yellow X locations. There's second floor joists going all the way back to here, and then it's boxed out for the stairway to go up. So this is the farthest, this is the last complete floor joist that there was, and obviously there's one at the front. So with the laser going in here, I put my tape measure, I sent it up and stuck it to the bottom of the floor joist. And this front one at both ends, and the rearmost one at both ends, and I got a distance from baseline or from laser line up. And it was quite clear. These three are within an inch of one another, which is well within reason for a building this old. I'd love it if it was a half of an inch, but I wouldn't even worry about an inch. It's this one that's like almost 3 inches different at the front corner that I was concerned about. So I plotted out in green the back of the building. That would be this cross section here. It's very desirable, quite plumb, and the triangle roof system, those can't change because you can't rack a triangle. There's no degrees of freedom. They're a fully justified closed shape. So then I plotted up 3 inches over here and over the 4 inches or so that it has migrated at this corner, and I took the green measurement for the wall as well as the distance out of plumb at 8 feet to scale. So this is the distance out of plumb here, and this is the distance out of plumb here, and I took that green length line and I plotted it from this location through that location over that distance, and I got this point here, and I did the same here. I took the length of the side of the building and I plumbed through where it originates, through where it's out of plumb, over that length, and I got there, and then I checked the distance between the two of them and the yellow triangle, and lo and behold, sure, they're the same as the distance on the green triangle, which was just checking my work essentially. And that's because the triangle should never change. So the two sides have moved and taken the base of the triangle over, which will take the rest of the triangle with you. So this bisecting line is done at 90 degrees here on the green triangle to its base, and this bisecting line went up at 90 degrees to the yellow triangle's base, long, and then I measured the length of a green side, and I started at this corner, and I went up and down this backbone structure here, this bisecting line, until I got to that length, and I put the point there, and then I came from that point to here and connected them, and then I checked that length versus the green length, and lo and behold, it's the same again. So once again checking my work, but that triangle system is just migrated as a result of the wall going up and going out, and it essentially is copacetic. Everything works out within tolerances at scale to my numbers that I found on the building. So it's clear to me that the front corner here has gone up, and they cut a hole for the garage door, and that walked off the foundation, and it has created the visual issues that we're seeing. So I I'm going to sell the client on the idea, I hope, of remediating this issue and this issue to begin with, and see how much closer to perfect we get. And as a last resort, we can pull a little bit, because it has spent some time in this position and it may fight us a little bit. We can always run out and grab it and pull a little bit more before, as a supplement, before we would sheathe the inside walls, which is going to be how I intend to preserve the condition that we put it into. We can get it back, but I highly recommend adding structural integrity by way of sheathing the inside of this entire end wall. And before we do that, we could pull a little bit if we need to get it perfect, ultra perfect, or even hyperextended a touch if we feel that it's pretty springy and may relax to perfect. So we have that available to us. And this would be that arrangement here. This is a top-down view of this area of the wall here, turned like that. So we've got the outside existing sheathing and the framing structure that's in here. And then I want to add 16-foot 2x10s and 2 layers, a pair of them. And then I would come outside and drill in various locations where I felt it was necessary along here to pull toward the tree, and drill in, and then we'll slide a forged lift eye through there, and we'll just sandwich some steel plate on either side of this thing, and we'll get a threaded lift eye so we can tighten the nut down on this side and that side and just create a nice sandwich here. And we'll make these locations work out right alongside a stud location. I would rather not pull and potentially bow a little bit into the wall bay. If I can help it, we'll pull right alongside a stud. That'll add some more integrity and relate more to pulling the wall out. But the idea that lumber and maybe even multiple locations at the same time would entice this to move and not damage anything here, and would just end up with some 1-inch diameter holes in the wall that we can go up and put a little sheet metal over and roll it out, the thin sheet metal patch, and roll it out the same color as the siding, and you just never know that we had been there. You can work to the building itself and build cleats on a lower corner and an upper corner and attach them and pull diagonally within the structure itself to rack it. That's an option that we might explore as well. But for right now, this is generally what I'm going to present. And I'll upload this video too, so this explanation for their reference, although we will go more into depth about this. But this is the sort of thing that I create for myself for my own reference. It's absolutely available to the client, or it belongs to them in this case. If we take the project one step at a time, we did a discovery day and prepare these materials, and I'll leave these with them for their consideration, and they can check out the video explanation as well. That's the least I can do, is to do an audit, basically. So that's the audit for this project, and hopefully we proceed in some way here. We're going to have to talk about our options, but look forward to that. We'll see you.